a quantity of grain estimated to be 100 ton shifts transversely by 10 meter and upward by 2 meter. So the grain shifts from this position to this position, say in this direction. So the transverse distance is 10 meter and upward distance is 2 meter. We need to find the list cause. So the list cause is tan theta list moment divided by capital W, which is the displacement, and GM. Here we should also note that the list moment cause is the final list moment, and the displacement is also final, and GM is also final in the list formula. So here let's work out with this one first, the list moment. Well, we can find the final list moment FLM by simply multiplying weight multiplied by distance. So the weight and this distance is a horizontal distance or a transverse distance. Well, we call transverse if the ship is, we are looking the ship in port and starboard direction. That is the transverse distance. So weight moved is in this direction. So now let us work out the list moment. Well, it is 100 into D, which is 10. So that gives me 1000 ton meter. And the direction of this list moment will depend in which direction the grain has shifted. Say in this picture, if it is shifted from port to starboard, so the list moment will be towards the starboard. However, if it was shifted from starboard to port, the list moment will be towards port. Now, WF is the final displacement. We didn't load anything, we didn't discharge anything, so the displacement given is 10,000 ton. So we have WF as 10,000 ton because we just shifted only. There is a shift of cargo, no loading or discharging. Now the third part, the GM final. Well, GM is already given, which is 1.5 meter. However, there is a shift in upward direction and this will affect the GM, so we need to calculate the final GM. Well, we can find the final GM by considering this effect of vertical shift. So first let me write the formula that GG1 will be W into D divided by W. F, again the final W is used here, and this shift is in upward direction. Say the G was here and M was here. So GM is given as 1.5 meter. Now I had shifted, so let's find out this W, which is going to be, W was 100 and the distance shifted is 2 divided by 10,000. WF is the same because there is no loading or discharging. So this will, let's work out. This cancels. So it gives me 0.02 meter. Now if we look at this, so K is here, G is here, and M is here. Since there is a shift in upward direction, there is a shift in upward direction. There is a shift here in the upward direction, so the G will also shift upward. So G1. So new GM, let me mark here, new GM will be the old GM, which is a GM minus a GG1. So it is going to be 1.5 minus 0.02. So this will have 1.5 minus 0.2, which is 1.48 meter. So now we have all these three parameters. We have the GM, we have final displacement, and we have the list moment also. All we need to do, put all these values in this formula. Tan theta is equal to final list moment divided by WF into GMF. So let me just put these values. So I get tan theta, final list moment, which is 10,000, divided by, no, this is 1,000. List moment is 1,000. This is the list moment. 1,000 divided by 10,000 into 1.48. Well, I just need to cancel this. So I get 1 by 14.8. So 1 by 14.8 gives me 0.067567, and all I need to do is get the tan inverse of that. So tan inverse of this value will give me theta, which is 3.8654617, or simply theta is equal to 3.9 degree port or starboard. It will depend where the grain has shifted.